winces slightly. We all know the sudden sting of a paper cut. 1 second, your skin is perfectly intact, and the next, there is a physical gap sliced right through your tissue. That tiny injury is a highly visible form of damage, but your body is actually losing cells at a massive rate without you ever noticing. Through regular friction, digestion, and daily wear, you shed roughly 50 billion cells every 24 hours. If those lost cells are not immediately replaced, the structural math works against us quickly. Within a matter of days, the physical architecture of your organs, muscles, and skin would simply waste away. To understand how the body solves that math problem, we have to look past the visible wound. If we plunge beneath the surface of the skin and into the microscopic architecture of the surrounding tissue, we eventually hit the command center of a single cell, the nucleus. Inside this dark space, the body manufactures precise microscopic replacement parts. To successfully patch the gap left by the paper cut, it must duplicate 3 billion lines of genetic code from scratch without corrupting a single design instruction. Curious, observant, you might expect this fluid environment to be chaotic. Instead, it operates as a highly organized staging ground. Those luminescent threads are loose strands of DNA, floating in suspension, waiting for a specific chemical trigger. When the cell receives the signal that tissue has been damaged, it initiates a mechanical sequence called mitosis. Mitosis is a highly choreographed molecular assembly line designed to execute a flawless division. The very first step is prophase. Before the cell can safely divide, it faces a logistics problem. It has to move all of that loose, delicate DNA across the cell without snapping or tangling it. This diagram illustrates exactly how the cell protects that material. It tightly winds those loose threads into dense, highly transportable packages known as chromosomes. Spooling the genetic code into these rigid structures ensures the blueprints survive physical transit. With the packages secured, the cell shifts into metaphase. The chromosomes drift through the fluid and snap into strict alignment, creating a precise border exactly down the middle of the workspace. Microscopic cables called spindle fibers shoot outward from the edges, locking onto both sides of every single package. The entire system is now loaded with tension, ready to pull. This geometric alignment serves as a strict biological failsafe. If a single chromosome drifts even a fraction of a millimeter off that center line, the cell chemically halts the entire sequence to prevent corrupting the genetic code. For a microsecond, the fully assembled apparatus sits frozen in the fluid. The cell verifies the tension on the cables, ensuring every lock is secure. Once the geometry is confirmed, the cell triggers anaphase. The careful, silent preparation gives way to explosive physical action. The tension releases. The packaged blueprints fractured cleanly down the middle. These newly split pieces are called sister chromatids, identical copies of the exact same instructions, and the cables violently rip them toward opposite poles of the cell. The pulling ends during telophase, as the chromatids arrive at their destinations. You now have 2 distinct, identical clusters of genetic material securely parked far away from each other. The cell immediately starts the rebuilding process to protect them. New physical membranes form to encase the exposed code, locking the instructions away inside 2 brand new nuclei. Finally, in a phase called cytokinesis, the outer wall of the main cell collapses inward. It tightens like a drawstring until it completely severs the connection. Using strict alignment and sheer physical tension, one master blueprint has successfully manufactured 2 fully functional cellular machines. If we pull out of the microscopic world and rush back through the layers of tissue, we can see exactly what that sequence achieved. Back on the visible surface, the tiny pool of blood has dried. The gap created by the sharp paper edge has physically knitted itself back together with fresh, structurally sound skin. Healing that one tiny cut required millions of individual cells to execute that exact division process. Across your entire body, mitosis successfully fires roughly 2 million times every single second of your life. Those distinct phases of alignment and division operate as a continuous, silent engine, working constantly in the background to ensure you remain healed, whole, and alive.